Hi kids, happy Saturday morning. I wanted to go through how you'll calculate some of the data for your free fall lab. And I know that from years past, I know this can be one of the trickier parts of the lab, and I don't want it to be that way. So what I've done, you can see I put in one set of data here, and what you guys will be doing is 4 to 5 heights if you can. And please notice you don't want to use any heights less than 2 meters when you do this. So this might be tricky, and we'll talk about it in class, because you've got to have a place that you can drop a ball from that's greater than 2 meters. So like I can use my back deck, and we used to do this in the commons at the high school. But let's say I had a height of 2.5 meters here that I'd measured out, and I dropped the ball 3 times, and I got these 3 data points. Another thing to notice, in the directions, I said if you get data that's very different, you should redo that trial. So like if I was getting stuff here that was maybe 0.8 something or 0.5 something, that would be pretty different. And sometimes kids think these are different, but the range of these is 0.05 seconds, which isn't really that much of time. So this is pretty okay data here. So to average my time here, what you'll do for the average time is you'll add these 3 up, and since you have 3 points there, then you would divide by 3. So I haven't done this yet, but so I just get my calculator out, and I have 0.7 plus 0.73 plus 0.68, and then I divide that by 3. And so that gives me 0.70. And it's got more decimals with it, but if you give me 2 decimals, that's just fine. Some of you want to pay attention. If you get a number here that doesn't look like it could be the average of these, then you probably calculated it wrong. So some kids are giving me a number here this was 1.3 or something. You know that you calculated it wrong, because that can't be the average of those. So then let's look at how we would calculate these other things. So my average velocity, so you know how to do that by now. So average velocity is distance, which in this case is our height, divided by the average time. So once I've found my average time, I can then calculate this. So I would do 2.5 divided by 0.7, and I get 3.57. So my average velocity now I know is 3.57. Now my initial velocity when I drop the ball, so I'm letting it go, it's falling down. So right when I let it go, its initial velocity is 0. And that would be true for all of these. So you could kind of fill that in right away. You know the initial velocity is 0. Now, this is the trickier one. And conceptually, you've got to understand what's happening. And so if I have a ball that starts at 0, and I need to know how fast it's going right before it lands, what I've got to think about is you already know the average velocity. So let's say I had a ball that started at 0, averaged 5 meters per second. Well, 0 and what number would give me an average of 5? If you can do that in your head right now, you're thinking, oh, 0 and 10 give me an average of 5. So what you've got to do for this, the final velocity here, and this only works out because our initial is 0, but the final velocity is going to be, one way to think about it is 2 times the average velocity. Did that come up with that X? You can't see that, huh? So it's 2 times the average velocity. So in this case, 2 times, I take 3.57 times 2, give me a value of 7.14. So that's what I would report in here. You don't have to type this whole thing in here, But conceptually, I want you to understand that, and we'll talk more about it in class for sure. But when you're doing this, know that the final is twice the average, and that's only because this is 0. Then when I calculate my acceleration, I look at my change in velocity over time. So we know that as the definition of acceleration. So to figure out my change in velocity, I take my final velocity minus my initial velocity. And I have to do that first. So I'm going to put those in parentheses. And then I divide that by time. And you can't see the divided sign on there, so I don't know why these little things pop up here. I wish they weren't there. But so in this case, the beauty of these is that final minus initial for all of these, if I'm subtracting 0, it's really just using my final velocity and dividing that by my average time. So in this case, then, I would have 7.14 divided by 0.7, and that would give me 10.2. So that's my acceleration value. So again, that's how you'll do your data points here in order to calculate, well, really we did the average time too, so in order to calculate all those things right there. How do I stop recording? There we go.